friends, my name is Nisha Thakur and I'm a maths online tutor. I'm the founder of Nisha Tutor. We say that A is a lower bound and B is an upper bound for the zeros of a polynomial if every real zero C of a polynomial satisfies A less than or equal to C less than or equal to B. So this theorem helps us to find such bounds for the zeros of a polynomial. Here is the upper and lower bounds theorem. Let P be a polynomial with real coefficients. First rule, if we divide Px by x minus b and with b greater than 0, it means b is positive using synthetic division, and if the row that contains the quotient and remainder has no negative entries, then B is an upper bound for the real zeros of P. And second rule, if we divide Px by x minus a with a less than 0, it means a is negative. Using synthetic division, and if the row that contains the quotient and remainder has entries that are alternately non-positive and non-negative, then A is a lower bound for the real zeros of P. I'm explaining with an example. Upper and lower bounds for zeros of a polynomial show that all the zeros of the polynomial Px lie between minus 3 and 2. So Px divided by x plus 3 and x minus 2. We will use synthetic division method. Okay. For synthetic division, uh, here this is dividend, and we write here coefficients of the terms. X to the power 4, here coefficient is 1. X to the power 3, no, so it means we insert here 0. X square coefficient minus 3, x coefficient 2, and constant minus 5. Okay, we divided by 2. Now bring down here 1. 1 times 2, 2, and write here 2. 0 plus 2 is 2. 2 times 2, 4. We write here. Minus 3 plus 4 is 1. 1 times 2, 2. 2 plus 2, 4. And 4 times 2, 8. 8 right here. Minus 5 plus 8 is 3. So here remainder is not a 0. It means 2 is not a 0 of the given polynomial. And here all entries are means quotient and remainder all are positive. So let's check. According to this theorem, if we divided Px by x minus b and b is positive, using synthetic division, and if the row that contains the quotient and remainder has no negative entry, then B is an upper bound for the real zeros of P. It means we can say 2 is an upper bound of the given polynomial. Okay. Let's check for this second. A is when A is less than 0, it means this. So we can use synthetic method, synthetic division method. Write here coefficients 1, x to the power 3, here no term, so we can insert 0. Now minus 3, 2, and minus 5. Okay, and divided by minus 3. Okay, negative. Now here bring down 1. 1 times minus 3 is minus 3. 0 minus 3 is minus 3. Minus 3 times minus 3 is 9. Minus 3 plus 9 is 6. And 6 times minus 3 is minus 18. So minus 16. Minus 16 times minus 3, 48. And minus 5 plus 48 is 43. So here alternate entries, positive, negative, positive, negative, positive. Okay. So according to this, if we divide px by x minus a and a is negative less than 0 using synthetic division, and if the row that contains the quotient and remainder has entries that are alternately non-positive and non-negative, then A is lower bound for the real zeros of P. So we can say minus 3 is a lower bound. Okay. So we can say that by the lower and upper bound theorem, minus 3 is a lower bound and 2 is an upper bound for the zeros. Since neither minus 3 and nor 2 is a 0, because remainder is not 0, all the real zeros lie between these numbers minus 3 and 2. Okay. So very simple question. If you know this theorem, the upper and lower bound theorem, and you know these two rules, so you can easily find out upper bound and lower bound. And if you get remainder 0, it means that is 0 of the given polynomial, otherwise not. If you have any doubt, please ask me, and if you liked my video, so please like, share and subscribe my YouTube channel. Have a great day.